In this lecture, we'll discuss about multiplexer problems, nothing but implementation of any boolean expression or implementing any circuit by using multiplexer. Okay. For example, if the expression is a 4 variable expression, for example, or if the circuit contains 4 inputs. Okay. So if they ask to implement with 16 by 1 mux, that is one kind of problem. Same Fourier variable they may ask to implement with 8 by 1 muxes. They same 4 variable they will ask to implement with 4 by 1 muxes also. So these kinds of all problems we have to know. So if they ask 4 variable with 16 by 1, it's like a direct problem. Just one 16 by 1 multiplexer we need. We don't need any implementation table. Because 4 means 2 power 4, how much 16 in that case. Okay, but if they ask with like this, we need implementation table and we need only one 8 by 1. But if they ask like this, we need implementation table and we need two 4 by 1s and one 2 input target at the output. Okay, these all problems I will explain. So this is the first problem. This is the 4 variable expression they given and they asking with 8 by 1. Okay. So this is a 3 variable expression only, not 4 variable. Okay, so 3 variable expression just with 8 by 1, how to do we'll see. So we don't need any implementation table because 2 cube equal to 8 na, 3 means 2 cube if you do 8 by 1. Okay, right. So they only will give expression SOP or POS or they only tell the size of the mux also. Okay, now just a minute, it is saving. Okay, now I will take 8 by 1. Whatever the data inputs they given, those I will assume as select inputs. So if there are 3 selects, I need 8 by 1 multiplexer. Okay, here they also told we have to take 8 by 1. Okay, 8 data inputs. These data inputs 0 to 7 and one data output. This is the expression. Whatever they given f, that will be the expression. Okay. So here in this, what if it is SOP, whatever the values they given, those values you connect to 1, logic 1. Whatever the values absent, with the 2 cube you will get 8 combinations. Out of 8 possibilities, whatever you given, those are ones, remaining will become zeros. Suppose if it is a POS expression with same 8 by 1, then whatever the given values, those will you have to connect to zeros. Remaining values you have to connect to absent values to 1. Okay, right. Now same 3 by 1 3 variable expression, if they ask with 4 by 1 multiplexer, then we have to take 4 by 1 and we need implementation table. So 4 by 1, 4 data inputs, 2 select inputs and 1 output. So out of these 3 inputs, this last 2 inputs I will assume as select, this will remain because this 4 by 1 can take only 2 na. Okay, 2 selects. Okay, now we have to do implementation table. In the table whatever we left, that we have to include. So this variable can get 2 possibilities, a bar na or a bar a. Okay, right. A bar means 0, a means 1. So we start with 0 na, so write 0 and 1 here. Okay, a bar a. So now how many inputs we get to this 4 by 1? 4, D0, D1, D2, D3. Those you can write here. Whatever the inputs, you assume some x0 or D1 something, you write here. And with 3 variable expression, how many possibilities will get? 8 possibilities. You write half possibilities here and half possibilities here. 0 to 3 here, 4 to 7 here. So we can start writing D0 here or this side also. But wherever you start D0, there only you start to 0. Wherever you start 0, there only you start 4. Suppose if I write D0 here, 0 and 4 will be here. 0, 1, 2, 3, 4, 5, 6, 7, like that. Now after writing this, whatever the values they given, if it is SOP, whatever the values they given, round those values here. If it is POS, whatever they not given, round those values. Okay, remember. So it is SOP, whatever they given I rounded. Now you see column wise. If all values rounded you will get 1. If nothing is rounded you will get 0. If any one is rounded, straight to that what is there? A. Here this only one rounded column wise. So straight to that A bar is there. So here 6 only, so A. Here 3 only, so A bar. Now D0 equal to 0, D1 equal to 1, like that. So here D0 you connect to 0, for D1 you connect this one, and whatever the values you got you connect. Now implementation completed. Okay. Now we'll see one more problem. Suppose now they given 4 variable expression, but they asking with 4 by 1. They asking with 4 by 1. So now in this case we need 2 4 by 1s and 1 OR gate at the output. The 2 4 by 1 outputs we have to connect to OR gate, that will give the final expression. So if this is 4 by 1, we can connect only 2 variables. So out of these 4 variables, last 2 you connect here. This first 2 you include in the okay. Alright. So we have to do change, just a minute. This last 2 we connect here, and one variable, first variable we include, and another variable we take, whatever the B remain, that we have to take as a enable. Okay, for one mux we have to keep bubble. So now this is enable. So this enable is nothing but which value? B. Okay, right. So now in the implementation table I take an A bar A, and with 4 variables you will get 16 possibilities. You write half, means 0 to 8 here and remaining here. Wherever you start 0, there only you start D0, there only you start 0. Wherever you start 0, there only you start 8. Okay. So this is SOP, whatever the given values you round. If it is POS, whatever not given, you round those. Okay. Alright. So when rounded, you take that all rounded 1, no rounded 0. When anyone rounded here, this rounded, so A bar. Here this C. Okay, you know how to do this, how you will get, I explained in the previous. Okay, now these values you connect here. So this 4 by 1, first 4 by 1 D0 to D3, second 4 by 1 D4 to D7. I told we need to take 2 4 by 1s. Okay, so D0 to D3 values, whatever values. So this is D0 A bar. So for D0 A bar, like that you connect all values. Okay, so here one variable is connecting to inputs, or we use it in the implementation, and 2 variables we given as select. Okay, and one we using as enable, and these outputs we connected to OR gate. Okay, now so this is the design. Okay, right, completed. So now you can do almost all kinds of problems, but one more thing you have to know. Suppose in the expression, if there are don't cares, that don't cares, if this is SOP expression, that don't cares also connect to 1 in SOP. In POS, don't cares also connect to 0. Suppose in this case you include don't care also in the table. Okay, and if it is SOP, don't care also round. Okay, in POS also don't care also round. Those also you have to include. Okay, right.